In this lesson, we're going to be talking about similarity that happens in right triangles, specifically when you draw an altitude to the hypotenuse. All right, so I have a right triangle drawn here, this big, the black right triangle, and then I drew in an altitude right here to the hypotenuse. So what happens is that altitude divides that big right triangle into two smaller right triangles. Okay, so I call it the small and the medium. All right, just to distinguish between the three. So notice, because it is an altitude, we do have those right angles that I have marked. So now let's think about the other angles. So if I look at the big triangle, okay, I'm going to mark this angle here with one tick mark, and I'm going to mark this angle here with two tick marks. Okay, so now I have this big right triangle, okay, the large right triangle, something like this, that has one tick mark here and two tick marks here. Okay, now I'm going to draw two more right triangles that kind of look like it. One's going to be medium, so this is a large. Here's my medium, and here's my small. Okay, we know they all have right angles. Okay, but look at this medium triangle, this blue triangle here. Now, this triangle right here and the big triangle, notice they have to be similar because they both have the right angles and they both have one tick mark, right? They share this angle. All right, so I'm going to go ahead and mark that angle as well. So if I look at these triangles over here to the right, the medium and the large are going to have to be similar because of angle. And we know two triangles that are similar, all their corresponding angles have to be congruent. So this triangle here must have two tick marks. Or I'm sorry, that angle there must have two tick marks. Okay, now look at our small triangle compared to the large. Okay, so that small triangle, again, they're going to have to be similar, right? Or they're going to have to both have right angles. I'm sorry, they both have the right angles. Right, and we also now know that, I've lost my pen, sorry. We also know that that top angle there is going to have to be congruent. We have a two tick mark there. And so the final angle must also be congruent in the triangles because the two triangles are similar. All right, so really we have three similar triangles. So the altitude divides it into three similar triangles. Okay, I could have also in here finished marking my angles. So for instance, in this blue triangle, because I already have a right angle and a one tick mark, this has to be a two tick mark. Because I already have a triangle, the red, because I already have a two tick mark, this angle would have to have a one tick mark. Okay, so that's another way for you to see it. So here's where the geometric mean comes in. The geometric mean is used to find the length of the altitude. So the altitude is the geometric mean of the two parts of the hypotenuse. Okay, so that altitude is dividing it into two parts, right? So I just called it A and B here. So our formula, according to what we know about geometric mean, would say that A over X is equal to X over B. But let's see why that is. Okay, so I'm just going to do this to show you how this all works. So let's think again. I'm going to mark my angles. Do one tick mark here, two tick marks here. For the big triangle, that means I'm going to have to do the opposite on the other angles, right? So I'm going to draw my three triangles. So I have the big one that looks like this with 1 and 2. I'm going to have a medium one that looks like that. Excuse me. And I'm going to have a small one that looks like that. All right, and I'm going to go ahead and match up my angles. All right, so we're going to call, this is going to be the medium, and this is going to be the small, okay? So the medium, well, let's do the big triangle first. On the big triangle, the only thing I have here is A plus B, right? That entire length of the hypotenuse. Let's think about the medium. Okay, here's my medium triangle. That medium has an X that lies between the two tick marks and the right angle. Okay, so the X lies between the two tick marks and the right angle. So this would be x. The b lies between the right angle and the 1 tick mark. So the right angle and the 1 tick mark. All right, now let's look at the small triangle. The x lies between the 1 tick mark and the right angle. And then the a lies between the right angle and the 2 tick marks. So here. All right, so we can just match up parts. So we can do x over a equals b over x. Now, granted, it does look a little bit different here, but remember, we're really going to cross multiply. So in the end, we still get x squared equals ab. Just like up here, if I'm cross multiplied, I'd have x squared equals ab. All right, but drawing out these triangles every time is just tedious. All right, so that's why we bring in the geometric mean. So the length of this altitude, the length of the altitude is the geometric mean of its 2 parts. Okay, so let's solve for x. X is going to be our altitude. So the altitude is the geometric mean of my 2 parts of my hypotenuse. So I really just need to find the geometric mean of 12 and 4. So 12 over x equals x over 4. So x squared equals 48. So when I take the square root, I would have x equals, it'd be the square root of 16 times the square root of 4. No, 3, sorry. Square root of 3. So that would simplify to 4 radical 3. You could also type that into your calculator, right? Figure is good to practice our radicals. All right, now a little twist. Okay, remember the altitude is the geometric mean of the 2 parts. So when I go and create my fractions, right, I need to make sure, since this is my altitude, they need to be opposite of each other, right? They need to be diagonal. And then these are my other 2 parts. So I'd have 6x equals 64. Divide by 6. And you get 10.6 repeating, or 10 2/3. So I can just write I'll just do 67. All right, so that's the altitude. We can break those triangles down again to find other parts. So now we're going to look at the measure of a leg. So the measure of a leg of a right triangle is the geometric mean of the hypotenuse and the adjacent part of the hypotenuse. All right, so I'm going to pause my end of the video. I'm going to redraw these triangles real quick, and then I'm going to start recording again. All right, through the magic of movie making here, I have all those triangles drawn out for you so you don't have to sit through that boredom. Okay, so now what I did is I drew my large, my medium, and my small again, and I went through and labeled the parts. As you can see, the medium triangle really doesn't play a part in this one for us. Okay, so we're just going to kind of ignore this one because it only has 1 part labeled. So this time we end up comparing the large triangle to the smaller one here, or the one on the left. Okay, so if we set up our proportion, because we know the triangles are similar, we'd have x over a equals a plus b over x. Okay, so I did x over a equals a plus b over x. Again, cross multiply. Okay, so it'd be x squared equals a times the quantity of a plus b. And a plus b is the hypotenuse of the whole, of the big triangle. Okay, it's the whole hypotenuse. So it's the geometric mean of the whole hypotenuse and the adjacent part. So the a was adjacent to the leg we're trying to find. Again, tedious to draw everything out. So let's take a look at an example. Okay, so we want to find x. X is a leg. All right, x is a leg. So the leg is the geometric mean. So I'm going to put my x's opposite of each other. Geometric mean of the whole hypotenuse, which we can see would be 16, over the adjacent part. So this side is adjacent, so it would be 4. So I have x squared equals 64. Take my square root, I would get 8. Okay, now we're going to do the exact same problem, but we're going to find the other leg. Okay, so notice I still have my 4 and my 12, but this time I'm finding a new side, a new leg. All right, so this time, since this is my leg, this side would be the adjacent. So the leg is the geometric mean of the whole hypotenuse, which is still 16, but this time it's over 12, because that's its part of the hypotenuse. So we have y squared equals 192. Take the square root of that, and you get 13.9. All right, so we're going to do one last problem here. I have all 3 parts labeled, so we have to know what we're finding, whether a leg or an altitude. All right, so let's just go in alphabetical order here. So x is a leg. Okay, so we know the leg is the geometric mean of the whole hypotenuse, which is 12, over its adjacent part, which is 9. So we have x squared equals 108. Go ahead and we'll just do decimals on this. We'll just take the square root of 108. Gives me 10.4. All right, now let's go alphabetical order again, gives us y. Okay, so y is a leg, 3 is the adjacent part. So we know the leg is the geometric mean of the whole hypotenuse and its part, so 12 and 3. So y squared equals 36, so y has to equal 6. All right, now we're down to z. Okay, z is the altitude. Z is my altitude, so it is the geometric mean of the 2 parts of the hypotenuse, so 3 and 9. So z squared equals 27. Take the square root of that, it's going to be 5.2. So z is equivalent to 5.2. For this assignment, you're going to be doing some Delta Math. Your quiz is also in Delta Math. So the assignment, you can miss them, and that's fine. That's how you're learning. But when you go into the quiz part of Delta Math, you're going to get 10 problems, and whatever you get, that is your score. So take your time, think through it. It's not timed, so work through it. That is your quiz. The second part of Delta Math, I called it quiz, I think all in capital letters.